we are going to start topic 3, linear functions. We're going to start with 3.1a, domain and range of discrete functions. So make sure you have your note sheet to follow along with the video. Our essential question is, why are domain and range important in defining a function? By the end of this video, you will be able to determine whether a relation is a function. Function. 1-to-1, every input, x value, only has one output, y value. No domain repeats. So for a relation to be a function, you will not have any items in the domain repeat itself. Domain and range. Domain refers to the x values, horizontal axis on our coordinate plane. The range refers to the y values, that vertical axis in our coordinate plane. Again, this is our x-axis. Here is our y-axis. Continuous versus discrete. A continuous function has no gaps between x values. It can be a line or a segment. It's continuous. So from this x value of 1 to this x value of 9, all the points are continuous. There are no gaps in between. What we mean by discrete is when a function when the x values are not connected, there's gaps. So our red graph represents a continuous function. The blue graph with the points where the x values are not connected, this is a discrete function. Use the table to list the domain and range. Reminder, the domain is just the x values. So if we list the x values, we go in order. 1, 2, 3, 4, 5. Those are our x values. The y values, we have 11, 12, 13, and the 13 repeats itself. So we don't have to repeat every value. We only have to list it once. So if we list the range here, we can list 11, 12, 13, and be done, since these y values repeat. Is this a function? Ask yourself, are there any x value repeats? So if you look at the x values, do any of them repeat? If yes, then it's not a function. If there's no repeats, then it is a function. In this case, this is a function because there are no x values that repeat. They all have their own output. Use the graph. Is this continuous or discrete? Remember, there's gaps. These points are not connected. Therefore, this is a discrete graph because there are no gaps between the points. To list the domain, we need to list the x values. To list the range, we are going to list the y values. So if we start here at 0, 0, and we identify every point. This point here, we would go -4, -2. So this point, the x value is -4, the y value is -2. I'm going to list all of them so we can see what the coordinates are at each one. You'll notice I color-coded it. So when we go to list the x values, they're all the values that are in green. Those are our x values. There's 4 of them. Now you might say, well, there's 6 points. How can you only have 4 x values? Well, this x value of 3 repeats, and so does this -2, so we don't have to list it twice. To list the range, the y values, those are the blue points. And again, a couple of them repeat, so there's only 4 unique points. So those are the only ones we have to list. We don't have to list all 6 when the values repeat. We need to say, is this a function? No, this is not a function because the x values -2 and 3, that should say 3, not -3, repeat. So because these values repeat, -2 gets mapped to 2 and -2 gets mapped to 1, that makes it not a function. The 3 gets mapped to 1 and -2. It has two different outputs, not a function. Use the set of coordinate points. We're going to create a mapping diagram for the domain and range. Remember, the domain is just your x values. The range is the y values. So if we list our x values, we got -3, -1, 2, and 4. And our y values are the range, 2, 5, -5, -4, 2, and 5. When we map them, the -3 gets mapped to 2. That's the ordered pair. So we can map -3 to 2. We can map the -1 to 5. 2 gets mapped to -4. And 4 gets mapped to -5. When we use this mapping diagram, it becomes more obvious that each input in the domain has only one output in the range. Therefore, this is a function. None of the x values repeat. Each value in the domain maps to only one value in the range. Let's try another example. Create a mapping diagram. Again, domain and range, x values. So we got 1, 5, 7. Again, the 5 repeats, so we don't have to rewrite it. The range, -1, 0, 2. The 2's repeat, so we don't have to rewrite it. 1 gets mapped to 2. 5 gets mapped to 2. 7 gets mapped to -1. And the 5 gets mapped to 0. And here, with this mapping diagram, to determine if it's a function, you can see that the 5 gets mapped to two different values. The 5 is our repeat. Therefore, this is not a function. Use the relation, the domain. Okay, our domain is -2, 3, 4. The range is 5, 6, 7, 8. Is it a function? No. If you look at the 3, that gets mapped to 6 and 7. This value repeats. It has two different outputs. Therefore, it is not a function. Use the graph. Is this continuous or discrete? See, we have points that make it discrete because there are gaps between the points. For the domain and range, again, that's our x values and y values. So if we go to each point and write its coordinates out, that will help us list our domain. -5, -2, -1, 2, and 4. And the range is -3, -1, 0, and 4. Is this a function? Yes. None of the x values repeat. They have their own unique y values. Make a note. It's okay for the y values to repeat. Notice how the y value of 4, that's two different points here. It's okay for the y values to repeat in order for it to be a function. The x values can't repeat when it's not a function. So this one is, in fact, a function.